Directions. Solve each system of equations by graphing, substitution, and elimination. Then classify the system. Okay, we're going to start with number 1. Negative 4x plus 2y equals negative 8, and negative 2x plus y is equal to 3. So the first thing we want to do is solve this system by graphing. In order for us to graph, one of the ways that we can do this is to isolate the y, get the y by itself. And that way, we're going to be able to get it into the form y equals mx plus b, where we can figure out the slope and the y-intercept. So I start with the very first equation, negative 4x plus 2y is equal to negative 8. If I want to get the y by itself, I have to do plus 4x plus 4x. That cancels. So 2y is equal to 4x minus 8. Divide everything by 2. So I get y is equal to 2x minus 4. So my first equation, I was able to get y equals 2x minus 4. Now I'm going to do the second equation, which says negative 2x plus y is equal to 3. So to isolate the y here is a little bit easier because all I have to do is add 2x to both sides. That cancels, so y equals 2x plus 3. Now, before we even start to graph, you should kind of pay attention to the slopes of these lines. If you notice here, my slope is positive 2 or 2 over 1 because slope is rise over run. My y-intercept is negative 4. In my second equation, my slope is positive 2 or 2 over 1, and my y-intercept is 3. So if you notice, we kind of get the feeling that they have the same slope, which means that these two lines should be parallel because they have different y-intercepts. And so we anticipate that this is going to be two lines that are parallel, and they should have no solution. And a system that has no solution, we call it inconsistent. So we're going to go ahead and graph it now. Okay, so I went ahead and I created a coordinate plane, an xy axis. So now I have y equals 2x minus 4. The y-intercept is negative 4, so you go to the y-axis and you go 1, 2, 3, 4. You put a point at negative 4. From that point, you're basically going to follow the slope, which is positive 2 or 2 over 1, which means you have to go up 2 and over 1. So from the point, from the y-intercept, I go up 2 over 1, up 2 over 1. And so this is my line. Then I'm going to do this again, and I'm going to do it with the other line. So the other line has a y-intercept of 3, 1, 2, 3. And my slope here is up 2 and over 1. So I would go up 2 over 1, up 2 over 1. And so here is my second line. So as you notice, these lines look like they're parallel. Now you have to be very careful because obviously we're drawing this ourselves. I don't have a graph on graph paper right here. So you have to be very cautious. What will determine the fact that they are parallel is the fact that they have the same exact slope, but they have a different y-intercept, okay? So that tells me that these lines are parallel. And because it says to solve the system by graphing, you have to say that there is no solution, okay? You have to say that there's no solution. It's a must. If you only graph it and you haven't said there's no solution, you haven't answered the question, which is to solve the system of equations, okay? And then to classify this system, you would say that it is inconsistent. It is inconsistent. So this is how you solve by graphing. So now we're going to take the same exact problem and we're going to go ahead and solve it by substitution, okay? Now, in order for me to solve by substitution, you have to basically choose one of these equations to work with. We like to choose the easier equation. In this case, I am going to say that the bottom one is easier because I can very easily isolate one of the variables. It doesn't always have to be x, it doesn't always have to be y. It can be either or, but notice here, I can very easily get y equals positive 2x, okay, plus 3, because the 3 was already positive. And all I did was take the 2x over from the left-hand side to the right-hand side. So I chose the easier equation. Sometimes both equations are just as quote unquote easy, so you get a choice, you got to pick one of them. And then sometimes you honestly have no choice because both of them are not as easy, so you just kind of had to choose the best one that you can. In this case, y equals 2x plus 3, I'm going to now plug this information back in to the other equation wherever I see the y. Okay, so again, I started by choosing the easier equation, negative 2x plus y equals 3. I'm going to get the y by itself. I added 2x to both sides. I get y equals 2x plus 3. I leave that equation alone and I take that information and I plug it into the other equation. So here I go. I'm going to write negative 4x plus 2, but it's 2 times y. Whenever I see a y, I'm going to replace it with what y is equal to, which is 2x plus 3 equals negative 8. Now, the whole point of doing this is that I used to have two equations. Each one has two variables, so I can't do anything. But now I've reduced it so that I only have one variable. All I see are an x. So let's go ahead and solve this. Let's distribute. I get negative 4x plus 4x plus 6 equals negative 8. Notice it just so happens that negative 4x and positive 4x completely cancel. So I'm left with 6 equals negative 8. Now you and I both know that there's no way that 6 is equal to negative 8. That is not true. Therefore, because the variables have completely canceled, I know that there is no solution. And don't forget the second part of the question, which is to classify the system. This system is inconsistent because there's no solution. So that's the same exact answer that we got when we graphed it. It's just that now we're doing it algebraically. So now we're ready to solve the system by elimination, okay? And some books call elimination addition, others call it the cancellation method. So in order for us to eliminate one of these variables, you want to make sure that they have the same number in front of the same variable. Notice the x's are all lined up, the y's are all lined up, the equal signs are all lined up, the numbers are all lined up. Now, we need to make sure that we can cancel either the x or the y. And the way we're going to do that is that it has to have the same number in front. That's called the coefficient, the number that's in front of a variable. So it has to have the same coefficient. And you want to make sure one is positive, one is negative. So right now, neither one is ready to get canceled. So I'm going to have to multiply one of the equations. You got to make a choice. Let's say I want to go ahead and cancel out the y's. So I need the bottom y to be negative 2, which means that if the bottom is negative 2 and the top is positive 2, they will cancel. But you can't just change it to a negative 2. You have to multiply the entire equation by negative 2. So that's what we're going to do. We're going to take the entire bottom equation and multiply by negative 2. So the top equation right now hasn't changed. I'm going to keep it as is. The bottom equation, it's going to become positive 4x because negative times a negative is a positive. Then negative 2y, and that's going to equal negative 6. Draw a line, cancel. So notice 2y and negative 2y also cancels, which is what I wanted to cancel, and the x is canceled. So I'm actually left with 0 equals add negative 14. 0 does not equal negative 14. Both of my variables have completely canceled. So again, even by elimination, I still get the same answer. There is no solution. This system is inconsistent. So I just showed you the same exact problem, how to do the same exact one, 3 different ways, graphing, substitution, elimination, and we ended up with exactly the same answer. Here we have a new set of equations. Okay, this is a new system. We're going to do the same thing. We're going to solve it by graphing, by substitution, and by elimination. So number 2, 3x minus y equals 9, 5x plus 2y equals 15. The first thing I'm going to do is solve by graphing. In order for me to solve by graphing, I'm going to go ahead and get each equation and get the y by itself. So in the top equation, the 3x minus y equals 9. If I subtract 3x from both sides, I'm left with negative y. Remember that you have to divide everything by -1 because you literally have to get the y by itself completely positive. So that means y is equal to -3 divided by -1 is positive 3x, and positive divided by a negative is -9. So that's my first equation. I take my second equation, and now I'm going to go 5x plus 2y is equal to 15. Let's go ahead and subtract 5x from both sides and divide everything by 2. Okay, so I get y is equal to -5/2x. Leave that alone because that's going to be your slope. It's the number next to the x, so you actually want it as a fraction. But 15/2, I can make 7.5 because then I'm going to know how to graph it. So when you go to graph this system, this is exactly what it looks like. So if I start with the line that I did in blue, because y equals 3x minus 9, that was in blue, so I kept it the same color. What you have to do is go to the y-intercept, which is -9. So I went down to -9. You want to put a point at -9. From that point, you follow the slope. The slope is 3, or 3/1, which means that you have to go from this point up 3, 1, 2, 3/1. Here's my other point. And then from that point up 3, 1, 2, 3/1. I do it again, up 1, 2, 3/1, up 1, 2, 3/1, up 1, 2, 3/1. Okay, so I have all these points, and then I connect all those points with a straight line. So that's the line in blue. The line in green, I have y is equal to -5/2x plus 7.5. 7.5 is 7.5, so that means that you have to go between the 7 and the 8, and you put a point. If the slope is -5/2, which means that from the y-intercept, you have to go down 5 and over 2. Because we're at the halfway mark, you got to make sure that you are also at the halfway mark when you go down. So it's down 1, 2, 3, 4, 5, and over 2. 1, 2. Do it again. Halfway marks. 1, 2, 3, halfway mark, 4, 5, and then over 1, 2. Connect the points with a line, and then the point where they intersect, that is going to be your solution. Right here, it looks like they cross at this particular point. That's the point 3, 0. When you write your answers, you do want to write them as ordered pairs because these are lines that we're graphing on a coordinate plane. So this represents an ordered pair. Make sure you put your answer in parentheses. Because this system does have a solution, we say that this system is consistent and independent. Okay, when it has one solution, it's consistent and independent. Okay, consistent and independent. So one of the things that you should do is take your answer and plug it in. So if in fact the solution is 3, 0, 3 times 3 minus 0 should equals 9. And it does. 9 minus 0 equals 9. And if I go 5 times 3 plus 2 times 0, that should equal 15. And it does, and it works. So that is the solution to this system. So now I'm going to show you how to do this by the second method, which is substitution. Okay, so in order for me to use substitution, remember that you have to start by choosing the quote-unquote easier equation. In this case, I'm going to choose to work with the top equation, and I'm going to want to get the y by itself. So if 3x minus y equals 9, then I would subtract 3x from both sides. I get negative y equals 9 minus 3x, or negative 3x plus 9. But you have to divide everything by -1 because you have to get the y completely by itself. So y equals -9 plus 3x. Remember, negative divided by a negative is a positive. So I use the top equation to get the y by itself. And now what I'm going to do is that I'm going to substitute it into the other equation. So I go 5x plus 2 times -9 plus 3x is equal to 15. So I distribute 5x minus 18 plus 6x is equal to 15. So I have to combine like terms. 5x and 6x right here give me 11x minus 18 equals 15. If I add 18 to both sides, 11x equals 33. Remember to divide by the number next to the variable, which in this case is 11. So that gives me that x is equal to 3. Okay, 33 divided by 11, x equals 3. Then I take that value and I go back to where I started so that I can go ahead and plug it in there. So I get y is equal to negative 9 plus 3 times 3. So y equals negative 9 plus 9. So y equals 0. So my solution to this system is going to be the point 3, 0. And we call this system consistent and independent because there's exactly one solution. And like we did before, the way for you to check to see if 3, 0 actually works is to plug it back in to this equation. And notice we got exactly the same answer as we did when we graphed it. So now we're ready to solve the same exact equation by elimination. By elimination, we look, the x's here are lined up. They have to have the same number in front, one positive, one negative. The y's have to have the same number in front, one positive, one negative. They don't. Now, right now, it's easier to get rid of the y's if I multiply the top by 2, because then it'll make it negative 2 and it will cancel. So that's what we're going to do, okay? We're going to go ahead and take the top equation, the entire equation, and multiply it by 2. So I get 6x minus 2y is equal to 18. Notice that I distributed to everything. The one on the bottom I didn't touch. I didn't have to multiply the top and the bottom. Sometimes you do. Right now I didn't. What I mean by that is if you wanted to get rid of the x's, you could have multiplied the top by negative 5 and the bottom by 3. And then you would have gotten one of them to be negative 15, the other one to be positive 15, and they would have canceled. That would have worked also. But we chose to cancel out y. But we didn't get to touch the bottom one, so it stays the same. I just copy it over. Everything has to be lined up beautifully. The x's, the y's, the equal sign, the numbers. The y's cancel. You add, okay? You always add. That's why you want to make sure that one is positive, one is negative, so that when you add, they cancel. I get 11x is equal to 33, and when I divide by 11, x is equal to 3. Now that x is equal to 3, I can go back to any of the equations and I can plug it in. So if I choose the top equation, 3x minus y equals 9, and x is equal to 3, that gives me that 9 minus y equals 9, which of course y has to be 0. So my answer is the point 3, 0, and you would call this consistent and independent. So it's the same exact answer we've gotten every single time. We did the same exact problem, number 2, with either graphing, substitution, or elimination. Example number 3. We're going to do the same thing. We're going to do the same exact problem, graphing, substitution, and elimination. We're going to go ahead and start by graphing. In order for us to graph, we have to get the y's by themselves. So 4x minus 3y equals 1. I subtract 4x from both sides. I get negative 3y is equal to negative 4x plus 1. Divide everything by negative 3. Okay, it cancels. So y equals negative over negative here is a positive 4/3 x, and leave this as negative 1/3. In the other problem, if you remember, I actually changed it to a decimal, but because when I divided, it gave me a nice terminating decimal. This negative 1/3 is 0.33333 repeated, and so that's why I'm not going to go ahead and change it. I'm just going to leave it as is. The next equation says negative 8x plus 6y is equal to negative 2. I'm going to go ahead and get the y by itself by adding 8x to both sides. Okay, so what I did was plus 8x plus 8x, and that cancels. So 6y equals 8x minus 2, divide by 6, divide by 6, divide by 6. I get y equals 8 over 6x minus 2 over 6. These fractions can be reduced. Y equals 4/3 x minus 1/3. And if you notice, this equation and this equation match exactly. like they have the same exact slope, they have the same y-intercept. Therefore, I already know that in this case, I'm going to have infinitely many solutions because they're exactly the same line. It's going to be one line on top of the other. And when we have infinitely many solutions, we're going to call this system consistent and dependent. Okay? Consistent and dependent. Let's go ahead and graph it. We're ready to graph this. Remember that we actually ended up with the same exact equation. The y-intercept is negative 1/3. So I come down here and you try to go a third of the way. So it's not exactly a half. It's a third of the way. So that's the y-intercept, negative 1/3. And then you go up 4/3. So you go up 4. So up 1, up 2, up 3, up 4, and over 3. 1, 2, 3. So it shouldn't land perfectly. It should be also a third of the way. And then here is my line. Try to draw it as neatly as possible and as long as possible with arrows at the end. I kind of missed my point just a little bit. And then here we have the green line. So you do exactly the same thing. Here's my point, negative 1/3. You go up 4/3, up 1, 2, 3, 4, 1, 2, 3. And you have basically drawn exactly the same line. So these two lines are the same. They touch all the time because they're exactly the same. So we say that we have infinitely many solutions. And remember that you have to say that because the directions say to solve, okay? The directions say to solve each system. So you have to say that there's infinitely many solutions, and we call this system consistent. And in this case, it's dependent. One line depends on the other. Let's go ahead and solve this now by substitution and elimination. So for substitution, you have to choose the quote-unquote easier equation. This is one of those examples where we really don't have an easier equation, so you're just going to have to make a choice, okay? So 4x minus 3y is equal to 1 versus negative 8x plus 6y equals negative 2. In the second equation, at least everything is an even number, so maybe I'm going to go ahead and choose that one. So what I'm going to do here when I choose it is that I'm going to go ahead and get, I don't know, let's get the y by itself maybe. So then I got negative 8x plus 6y equals negative 2. If I got the y by itself, I had to add 8x to both sides. So 6y equals 8x minus 2. Divide everything by 6. And so I get y equals 4/3 x minus 1/3. No surprise here because that's exactly what we got last time when we did this by graphing. So what you do now, since I used the bottom equation, is that I have to work with the top equation, and I'm going to rewrite 4x minus 3 times. And instead of y, I'm going to replace it with what y is equal to, which is 4/3 x minus 1/3. So that's equal to 1. So all I did was copy the equation from the top. So now you want to distribute. So 4x minus 3 times 4 is 12. Divided by 3 is 4. So minus 4x. Negative times a negative here is going to be a positive. 3 times 1 is 3. Divided by 3 is 1. Is equal to 1. So something interesting happens. The x's cancel. So I'm left with 1 equals 1. 1 equals 1 is a true statement. So because it is a true statement and all of the x's and all of the y's have completely canceled out, we say that there are infinitely many solutions, and this system is called consistent and dependent, just like we suspected. Okay, so now our last thing to do is to actually solve this by elimination. So in order for us to use elimination, remember that everything has to be lined up. The x's, the y's, the equal sign, and the numbers, and they are. If not, you would have to rearrange them, but right now they are. So then you want to look at the coefficients, and they should match, one positive, one negative. Neither of them matches, so you're going to have to make a choice, either x or y. Which one do you want to change? Just choose one. It doesn't matter right now. I'll go ahead and I'll choose to cancel out the x's, okay? If I want to cancel out the x's, I want to make the top number 8. And so because I want to make it 8, I have to multiply the top equation by 2. So that's exactly what I'm going to do. I'm going to take the top equation and I'm going to multiply it by 2. So you distribute and I get 8x minus 6y is equal to 2. And then the bottom one is negative 8x plus 6y is equal to negative 2. And if you notice, the x is canceled, the y's cancel. I'm left with 0 on the left-hand side. And it just so happens that 2 minus 2 is also 0. So I'm left with 0 equals 0. Now, 0 equals 0 is true. Therefore, because all the variables have canceled, that means that there's infinitely many solutions. And again, this system is consistent and dependent, okay? So I have just shown you how to do 3 different problems, one of which was parallel, the other one was the same line, and the other one actually had 1 point of intersection. We did each one of those by graphing, substitution, and elimination, so hopefully this helps. Good luck!